Yes, Namita, am I audible?
Yes, sir, you're audible.
Okay, okay. Have you got the previous day what I have forwarded you? The Google Doc, that is the one which I have downloaded, the lecture.
Okay.
I've sent it in a Google Drive, the
Sir,
entire
I didn't receive it. It was just a forwarded message, but the content was not there in the email.
email. No, I'll forward the email again. It's in the Google Drive. So you have to go to the Google Drive and you have to download the
The
lecture.
document? Okay.
The lecture,
Okay.
the lecture. So it's in the
Okay.
Google Drive. It's
Okay,
around
fine.
750 MB.
Okay, fine,
The
fine. I'll do
previous
that.
day. Okay, okay. Yes, Sanjeevani.
Hello.
Good
Yeah.
evening.
Good evening, sir. How are you?
Fine. We'll continue today. Let us others join.
Yeah. No problem.
Hello, good afternoon.
Hello. Good evening, Khalid.
Good evening.
So we'll be starting today with NumPy. Okay. We'll be doing Python today and we'll see what is NumPy and how important it is, right? Let few people join in. So today we'll start with NumPy, right? And NumPy is very, very important library in Python. We'll do a lot of activities with NumPy. Yes, Hassan, good evening.
Yes, sir. Good evening. Apologies for being a bit late.
Okay.
Good
So I'm
evening to
waiting for
everyone.
Aparna. Aparna, I'm waiting. Abdul has joined. Yes.
इसका फॉर्मूला होता है
Good evening, Abdul. Okay. We'll be starting with NumPy today and we'll do a lot of exercise with NumPy, right? So I hope everyone can see the screen that I'm sharing. Is it visible? Abdul, Hassan,
Yes.
Khalid, Sanjeevani. Okay.
Yes. Yes.
Okay. So lastly, what we did is that a brief recap. We did with descriptive statistics. We did with standard deviation. We did with variance. We did with a calculation of mean for group data. We did calculation of mean for ungrouped data. We did calculation of mean with the data with frequency and class interval. Same, we did find the median for ungrouped data. We found median for a data with class interval and frequency. And similarly, we did for mode. We found the frequency for group data and ungrouped data with frequency. So these are the activities that we did in the previous class. Now we'll go ahead and we'll proceed further. So I hope whatever we did, standard deviation, variance, mean, median, mode, skewness, kurtosis, and also the measure of central tendency, the activities and the numerical, that is clear, and we are all on same page, right? Now we start with the new chapter today. The chapter is NumPy. Very, very important because when you do descriptive statistics and when you try to practically implement it, and you got a lot of activities and assignments with NumPy also, right? So what is NumPy? NumPy is a Python library. It's a core library for scientific computing in Python. So what we use a NumPy for? We use NumPy for core scientific computing in Python. It provides a high performance multi-dimensional data. What is a multi-dimensional data? A multi-dimensional data is n-dimensional array which will have rows and columns. So do you have any idea what is an array? So if you don't have any idea, so don't worry, I'll let you know. Array basically gives you a homogeneous data in consecutive memory location. It's a one-dimensional array. You can see 0, 1, 2, 3, 4, 5, 6, 7, 8. So basically, your data is stored in a consecutive memory location. So when we talk about multi-dimensional array, means the array will be having rows and columns. So when an array will have rows and columns, then that array is called as multi-dimensional array. So n-dimensional array of homogeneous data type means if an array is having an integer data, it will have only an integer data. It will not going to have a character data. So array stores data which is exactly of similar type. That means in array we'll have all homogeneous data. The array will not support heterogeneous data. Means in the array the elements that are stored are all of same type. So n-dimensional array with data types and with many operations that is performed in a compiled code, and we can see the index. The index is where the elements are located in an array. So where are our elements are located in an array, that we can find out with a given index. So a key to NumPy the array with many operations that can be performed. The array can be used for compiled code and for the performance. So it provides a high performance multi-dimensional array. That means which will have the rows and columns, right? What is NumPy? Very, very important because we need to have a very clear idea what is NumPy. So there are several important differences between NumPy and the standard sequence that we use in Python. So NumPy array have fixed size. They modify the size, meaning they create a new array. So NumPy array must be of what type? The NumPy array must be of same type. So that can include a particular Python object. So we cannot have a NumPy array which is of a different type. A NumPy array will be all of same type, right? So how do we create a NumPy array? It's very, very important when you are writing a code or when you're executing a code, there is a given syntax how we create a NumPy array. You have already done Python, so could you tell me in Python you have used list and tuples? So could you tell me what is the difference between a list and tuple? Can anyone tell me what is the difference between a list and tuple? Hassan? Hassan, can you tell me what is the difference between a list and tuple? Yes, Sanjeevni, could you tell me what is the difference between a list and tuple? Is the list and tuple same or they are different?
Actually,
Yes, you all
uh,
did Python basics, right? So
yeah,
you must have worked with list and tuples, right?
yes, yes.
So what is a list and tuple? Because when we do NumPy, we are discussing about an array. So there lies a comparison. What is the difference between a NumPy and a list and tuple, right? Because you already worked with list, you have done slicing and dicing on the list and tuples in your basic Python. Now in the advanced Python, you're using the libraries, you'll be using the libraries like NumPys and Pandas, and you will be also doing lot of operations on these libraries or on the array that you will be creating in Python. So list and tuples are basically a data type. One is mutable, other one is immutable. So which is mutable? List is mutable, tuple is basically immutable object in Python. And we store element in list which starts with the list index 0 and the last element is list index n minus 1. Similarly, the tuple, it starts with the index 0 and the last element in the tuple is also n minus 1, right? But if we
Hmm.
take the reverse of a list and reverse of a tuple, then we'll have the index as -1, -2, -3, and so on, right? Now, when we come down to NumPy, we have multi-dimensional array. Multi-dimensional array means if you take a matrix will have number of rows and columns. So in a NumPy, we can have a multi-dimensional array which can be represented through a row and column. So we can have an array with 2 rows, 2 columns. So we'll have number of elements as 4. If we have an array with 3 rows and 3 columns, then the number of element in that particular array will be 3 cross 3, that is 9. So it depends what are the elements that we are storing in the array, how these elements are being displayed, what are the various parameters that these array element carry plays a very important and vital role when we work on with NumPy, right? The second thing that we should know is the dimension and type. Every array will be of similar type. Means if an array is an integer type, it will only store integer element. It cannot go ahead and store a character element. So an array will always store element which are of similar type. That is a homogeneous element. An array cannot have a heterogeneous element, right? Now we can also have the dimension of an array. What are the number of rows and column in an array? That is called a dimension of an array. So an array can be one dimension or it can be multi-dimension, or we can have a shape of that particular array which we are using. Now every array will have a shape or it will have a dimension. Dimension shows us whether it is a two-dimensional array or it is a multi-dimensional array, whereas the shape of an array will show us with how many rows and columns the array is having, right? So we'll do some exercise on NumPy. So I'll go and share a Google Colab. And what you can do is that you can also do it side by side. So you know how we are doing or representing a NumPy array, right? So let me share the Google Colab screen so you can get through the NumPy. So this is a small Google Colab where we have created a NumPy array. ARR is a NumPy array. So it is a one-dimensional NumPy array which has only one dimension, right? Now if we can create another NumPy array, NumPy dot array, and we can give the element in the NumPy array. Suppose 22, 44, 55, 66, and 75. So this is again a one-dimensional NumPy array that we have created. Now I want to print both the NumPy array. So we created two NumPy array and displaying both the NumPy array. Are you getting this, everyone? Everyone can see the Google Colab screen. What we have done here, guys,
Yes.
we have created two NumPy array, right? With the first NumPy array and the second NumPy array. And what we are doing is that we are displaying the NumPy array 1 and we are displaying the NumPy array 2. So what we are displaying? We are displaying both the NumPy array, right? So we have created a NumPy array 1 and we have created a NumPy array 2 and we are displaying the elements in that NumPy array, right? Can we add the first NumPy array with the second NumPy array and can display the sum of both the NumPy array? Yes, we can do that. So if I add a print, if I write print ARR plus ARR1, so
Sir,
what we do here, we can
can you
give them,
zoom?
yes, I'll try to zoom it up a bit.
Yeah.
Is it visible now? Is it visible? So what we
Yes,
have
sir.
done,
Yes.
we have created two NumPy array and then we have added these element. So it is the sum of the first NumPy array and the second NumPy array. Sum of the first and the second array. So we have taken out the sum of the first array and the second array and we displayed it in the output. Similarly, what we can do, we can subtract these two arrays, right? How? If I write print like this, difference of the first NumPy array and the second NumPy array. So if we write like this, ARR minus ARR1, so we can get the difference of the first NumPy array to the second one. We can also print the product of two NumPy array. Product of two NumPy array, the first and the second NumPy array. Okay. And we can get the product of the first NumPy array and the second NumPy array. We can do a scalar multiplication of the NumPy array. Scalar multiplication of NumPy array. How do we do the scalar multiplication? If I write 5 into ARR1 and 10 into ARR2, so the first NumPy array will be multiplied by 5. All the element in the first NumPy array multiplied by 5 and all the element in the second NumPy array multiplied by 10 and then they are added. Are you all getting it, guys? Everyone is on the same page? Yes.
Yes.
Very good. We all should be in the same page, right? So we can create a NumPy array and we can add a NumPy array We can multiply a NumPy array. We can do a scalar multiplication of a NumPy array, and we can find out what is the outcome of the scalar multiplication that is being done on a NumPy array. Is it clear whatever we did till now? What are the arrays that we are working? We are working with one-dimensional array. How do we know what is the dimension of the array that we are working with? If we write the name of the array dot ending, it will show you the dimension. And if you write the name of the array dot shape, it will show you the shape of the array. If you write the name of the array and the size, it will show you the size. So let us do these attributes and see how these attributes can be represented in a NumPy array, right? So let us do it. So we want to see the dimension of a NumPy array. We can
So
see
can you
the
explain scalar multiplication? What's
yes,
that?
scalar multiplication means we are using broadcasting. So what is broadcasting means? Suppose I got a first NumPy array and I have got the element in the first NumPy array as 1, 2, 3, 4, 5. The element in the second NumPy array that we have is 22, 44, 55, 66, and 75. So
Yeah.
when we are going for a scalar multiplication means what? We are multiplying all the element of the first NumPy array with the 5. So 1 into
Okay.
5, 2 into 5, 3 into 5, 4 into 5, 5 into 5.
Okay.
Then the second NumPy array, we have the element 22, 44, 55, 66, and 77. 5. So what we are doing, we are multiplying all the element in the second NumPy array with 10. So it gives 220, then it provides you 450, then it provides you 565, 580, 680, and 775. So this is what is the scalar multiplication that is supported in case of NumPy array. So what we can do, it can support a scalar multiplication that can be done in case of your NumPy array. So NumPy array supports what? It does support scalar multiplication. So this is how the two array can be multiplied, and we can see what type of scalar multiplication these arrays are providing us, right? Now this is all arrays which we are doing are one dimensional array. One dimensional array means it will only have rows, it will not have columns. But NumPy provides us with a multi-dimensional array. So what is a multi-dimensional array? A multi-dimensional array is the one which will have the rows and it will also have the column, right? So how
Hmm.
we can go about a multi-dimensional array? But before that, is there any provision by which we can see what is the type of an array, what is the size of an array, what is the dimension of an array? Yes, we can see the dimension, shape, and size of an array. How it is possible? Let us see. Suppose this is our NumPy array. So I want to check the dimension. So if I write print and then we write smaller case print and then we write the dimension of the NumPy array. So ARR dot. Now what is the dot will be providing over here? Ndim. Ndim will provide us with what? The dimension of an array.
Okay.
Okay. So if we display, so it gives us the dimension 1 because it is a one dimensional array. So it is
Hmm.
giving the dimension as 1, right? But suppose we want to see the shape of an array or we want to see the size of an array. So how do we see the shape or the size of the array? So when we print ARR dot shape
Okay.
or print ARR dot size, so we can see the size of an array, we can see the shape of an array, we can see the dimension of an array. So first one is the dimension of the array. The dimension of the array. So what is the dimension of the array? That we can find out from here. Okay, then we can see what? We can see the shape of an array. Shape of an array. Then what we can see? We can see the size of an array. Size of an array like this. So we can see the dimension, we can see the shape, we can see the size. So dimension is 1, shape of the array is 5, and the size is also 5, right? So that is what we got for the first array. Now we can do the same thing for the second array. So we got 2 arrays here, right? So we can do for the second array also, which is ARR1 dot dimension ARR1 dot size ARR1 dot shape. So we can see the dimension, shape, and size for the second array. So if I add few more element into the second array, so the dimension and the size of the second array will be not the same at par with the first array, because both the arrays will have different dimension. Then we won't be able to add these array or multiply these array if the dimensions are changing. So we can take a third array so that we have a different dimension and a shape for the array number 3, right? Suppose I'm taking the third array ARR2, and here we write numpy dot array, and then we take a different dimension for that array. Suppose 2, 3, 4. This is the one dimension that you have taken for the array. So we can have more than one dimension for an array, or we can have a multi-dimensional array. Multi-dimensional array means the array which is having more than one dimension. Means it can have rows and columns. So the one dimension we have taken, this is the another row and column that we have taken. So, and I'll take one more dimension here. For instance, 5, 8, 9. So the third array that we are printing here, print ARR2. So ARR2 is the third array, and in the third array the dimension is not at par with the first two array, because the third array that we are using will have a different dimension as compared to the array with the first and the second dimension. So here we have how many elements? 3. So 1, 2. Now we see the dimension. Yes, so it has got, this array has got 3 rows and 3 columns. So how many elements the array has? 9 elements. Why the array is having 9 elements? Because the array that we have created are having 3 rows and 3 columns. So total number of element in the array that we get here is 9. So 9 is the total number of element in this particular array 2. So array 2 is a matrix. So this is the first array. So you can print the first array. Then you can print the second array. The second array. Then you can print the third array. The third array. And what you would see is the output for the first array, the output for the second array, the output for the third array. So, but the dimension size of the third array is not the same as the first and the second array. How do we know that? We can print the dimension. Print the dimension of the third array. So how do we print the dimension of the third array? We write ARR 2 dot ND. That will give us the dimension of the third array, right? We can get the shape of the third array. So we can print the shape of the third array. We can go over here and we can print the, instead of dimension, the shape of the third array. So ARR2 dot shape. Then we can display what? We can display the size of the third array. So how we can display the size of the third array? The size of the third array. Size of the third array. So ARR2 dot size. And when we display the output, we can see the dimension. So okay, comma has to be there. Now we can display same here also the comma after double quotes. Here should be a comma. Now we display the output where we see the dimension of the third array is 2. Because it is two dimensional, it has got rows and column. Now the shape of the array is 3 rows, 3 column, and the total number of element in the array is 3 into 3, that is 9. Are you all getting this? Everyone? I'm copy pasting this in the chat box, the entire code, so that you all can have a look. Got it in the chat box, everyone? Everyone can see the output screen and the code for the NumPy.
Yes.
Yes.
Okay. So what we have done? We have imported a library, NumPy. Okay, import NumPy, or you can write NumPy as NP. So if you write NP, then instead of NumPy, you can write np.array. np.array. So you don't have to write NumPy here. You can write NP. So if you are importing NumPy as NP, so you can straight away write np.array. You need not write numpy.array because np is an object for the library numpy, and we can straight away write like this, where we get the numpy array with 1, 2 and multiple dimension. Are we all on same page in this regard? Yes.
Yes.
Now what we can do is that we can add two multi-dimensional array. We can do matrix addition, matrix multiplication, matrix addition, multiplication, and subtraction. So we can create two multi-dimensional array in NumPy, and we can add them, we can multiply them, we can do a lot of operations with matrix. So how to implement a matrix algebra using a NumPy array? So in a NumPy array, we can implement a matrix manipulation. So how that can be done, right? So what we can do over here, everybody can see, I'll take a fresh code window and we'll create two NumPy array, which is a multi-dimensional array, right? So I'm going over here. So one is this array X and the other one is the array Y. Y is np dot array. Then this is also a multi-dimensional array that we are creating. And in this multi-dimensional array, what we are doing, we are giving the rows and column in this multi-dimensional array like this: 3, 4, then we can write like this 7, 8, 9, then we can write like this 2, 4, 5. Okay, so two multidimensional arrays are created. Clear? So if we print the first array, what we are going to get? Print the first array X, and then you print the second array Y. Now when you print these two array X and Y, you get this output. Now you have to add the two arrays. You have to multiply the two arrays. You have to find the difference of these two arrays. So which will result in matrix addition, matrix multiplication, and the subtraction of the matrix. Are we able to? This is the sum of two matrix. The sum of 2, 3 in cross 3 matrix. Now this is the product of 2, 3 cross 3 matrix. The product of 2, 3 cross 3 matrix. Then we can have the difference of 2, 3 cross 3 matrix. The difference of 2, 3 cross 3 matrix, right? So we can have the sum, we can have the product, and we can have the difference. Are we getting it, guys? Are you all getting this matrix manipulation using two-dimensional array? 2D array means two-dimensional. So we can check the dimension of an array. We can check the size of an array. We can see what type of matrix manipulation can be done on a given array. Are we all on same page in this regard?
Yes.
Very good. We can also see what type of array that we are dealing with. So whether our array is an integer array, whether our array is a character array, or whether our array is of any other type. Function that is type. So type function will allow us to find out the type of array that we are dealing with. So how we can find out the type of the array? So if I write print and then we write the function type, and in the function type we want to find out what is the type of the array X, or what is the data type of the array Y. So we can find out the data type of array X, and we can find out the data type of the array Y. How we can find out? Like this. So n-dimensional array, the class is multidimensional array, and a multidimensional array we can easily find out what is the data type of a multidimensional array. If you write D type also, you'll get the data type, D type. So I think the D type function is not taking over here. We'll use the type function or the ending function. So that will give us what type of multidimensional array or what type of one-dimensional array that we are working with, right? So we should know what is the data type of an array, and how is the data is stored in an array, and how do we access the data in a given array. So this is very, very important that we need to know what type of data we are working with and what is the data type of the given array. So are we all on same page in this regard, everyone?
Sir, in the output it shows class numpy.nd array.
ND array. Yes, it is showing the class because data type is also a particular class. So integer is the class,
Huh?
character is a class. So everything is a class because it is an object oriented programming language. So when you use an object oriented programming language, so everything that we are storing or everything that we are displaying is a data type. So
Yeah,
we
what is
can
the meaning?
define that its
Okay.
meaning that it is an array. The data type of that numpy is an array, and whatever the value it is storing, that is storing in the consecutive memory location. It is a homogeneous array. Homogeneous array means the array which will take all the element of similar type. So any array which has similar type of element and the class that can be identified by creating the type that we are trying to specify. Now we'll go into the details of that later on, but we should know that every array that we are dealing with has a certain index. Index means which value
Yeah.
that how do we find out the array index? How do we find out what is the element in the index 1? How do we find out the what is the element in the index 2, and so on? So we should know that when we have created an array, so obviously every element in the array will have certain index, and we can access those elements by their index. So instead of taking that element directly, if we can find out the index, then we can directly access that array as per the given index that we are using. So how that can be possible, or how we can find out the index? So suppose I'll take another code window and we create a one-dimensional array like this. Okay. So I've taken a one-dimensional array. Now I will print np, that is ARR of 0. So the first element is in the index 0. So which is the element it is printing? 1. But instead of 0, if I change it to suppose 4, so the element that it is printing is 5 because this has got index 0.
Yeah.
This has got index 1.
And two.
This has got index 2. This has got index 3. This has got index 4.
Oh,
But
yeah.
how many elements we have? Total 5 elements. But
Yeah.
the index are not as per the position of the element, right? The index starts from 0 to n minus 1. If n is the number of element in an array, then the index in that array will be n minus 1. Suppose if n is 10 element in an array, then the index will be 10 minus, that means the number of index starts from 0 to 10 minus 1, means 0 to 9. If there are 12 elements, that means 0 to 11, that is 12 elements. So the index will not start from 1, it will start from 0 and will
Oh,
continue to n minus 1, and it will continue till n minus 1. Is this clear? How do
yeah.
we do the indexing? Very important that we know how to index a numpy array. Because what happens when you create a numpy array, you should have a clear idea how and in what way the index that you have defined will be addressed. Means how you're going to take those particular index locations in a given numpy array, and how you're going to calculate the index, whether it is in the first position or it is in the second position or it is in the third position. Now I'll be giving an example where we will have a multi-dimensional array where the index will be different and their dimension will be different. So how do we know the index and dimension will be different? You can see this example. We got a array 1, array 2 is B, array 3 is C, array 4 is D. Now this is the dimension of the first array A, this is the dimension of the second array B, this is the dimension of the third array and the fourth array. So how do we know whether the dimension are same or different? You can see the dimension of the first array is 0 because it has got only one element and it has got index 0. The dimension of the second array is 1 because it's a one dimensional array. The dimension of the third array is 2 because it is a two dimensional array. It has got 2 rows and it has got 3 columns. It is 2 cross 3 array. The dimension of the fourth array is how much? The dimension of the fourth array is 4. Why 3? Why 0, 1, 2, 3? Because it has got 4 rows and it has got 3 columns. It has got 4 rows and it has got 3 columns. That is 4 cross 3. But the shape will be different. So if we print the shape with the dimension, and if we print the size, you can find out that they are different. I'm printing the shape. So what we can see that the shape and the dimension are not same. They are different in this case of NumPy array that we are using. So that's the dimension and this is the shape as we have seen earlier, right? So I'm copy pasting this code in the chat box. Matrix multiplication of an array, dimension of an array, and obviously we'll have the size and shape of an array. So if we include size also, you can see the size will not be the same. They will be different. The shape and size of an array will not be different. If I write size, the size of an array will be different. Size, then b dot size, then you got c dot size, then you got d dot size. So the dimension and the size of the array are not same. Here is the dimension, here is the shape, and here is the size. So you can also print dimension for first array, then dimension for the second array, dimension for second array, and you have the dimension for the third array, dimension for the third array. So it will explicitly specify the dimension for each array element. Then you have the dimension for the fourth array. And you can see how is the dimension different. Similarly, you can print the shape and size, and this is the output that you will be getting. So is this example is clear? How do we print the shape and dimension of a multi-dimensional array in NumPy, and how is the multi-dimensional array in a NumPy is working, and how do we define the multi-dimensional array in NumPy, right? Is it clear? Any doubts? Anyone having? Yes, you can ask me any question, any doubt, any queries that you find that you are stuck with and you don't understand with multidimensional array. Okay, I'll give you a exercise. You do it right now and show me. Okay, I'm giving that exercise in the chat box, right? Create 3 array using NumPy, add them and multiply them, perform scalar multiplication, and also display their size and dimension. Can you all do this one? I've given a question on the in the chat box. What you have to do? You have to create 3 array using NumPy, add them, multiply them, perform scalar multiplication on them, and also display their dimension. Can you do this? Can you all try this one right now?
Yes.
Khalid, Hassan, Abdul, can you do this thing?
So three-dimensional,
Yes,
right?
yeah, you can do 3, you can do 2. It is as per your choice or convenience how many dimensions you want to add to the array. It can multiply these arrays, you can find the product, or you can find the size of these arrays, right?
Yeah. Okay, sir.
And once you do that, do share your code and your output in the chat box, everyone, one by one, right? So that I know that you have done this. Okay, are we all on same page, guys? Are we all on same page?
Yes.
Okay, do this dimension and check the dimension and tell me what is the dimension. Then we'll do with the slicing and dicing in the NumPy array, how we can do the slicing and dicing in a NumPy array. And we'll see some function also, such as a range function, line space function, random randit function in the NumPy array, right? We'll do slicing and dicing. We'll see some functions that we can use in the NumPy array. Everyone doing it? Are we all on same page? It's very important that we should be in the same page, right? So we got the line space function, randit function, a range function. We'll see this function, how it works. Shape and size and dimension function we have already done. D type also, we can find out the D type of that array, right? If I write np dot D type, suppose will give you the data type of the first array, data type of the second array, data type of the third array, data type of the fourth array. So we can find out what is the data type of the first array, what is the data type of the second array, what is the data type of the third array, right? So not only you can display the shape, size, and the dimension, you also can go ahead and display the data type of the NumPy array that you are dealing with, right? You can display the data type of the NumPy array that you are dealing with. I'm displaying everything in the output in the chat box. You can also share your output in the chat box.
Sir, can you go up?
Yes, sure. I'll go up here. Yes. Is it visible?
Yeah. Mhm.
Even I pasted the entire code in the chat box. You can see the chat box also.
Yeah.
The entire code is pasted there.
Yes, better.
Everyone is doing this one, this particular code. Now we'll go ahead with the other code where we see a few functions in NumPy array, such as line space function, arrange function, reshape function, right? Shape, we have already seen how we can work with the reshape function. Data type also we have seen how we can see a particular data type of a NumPy array, right? We can see the size, dimension, data type of a NumPy array, right? And then we can see a line space function, and we can see a np dot zeros and np dot one. So how we can create a zero array and one array using NumPy, and how we can arrange a NumPy array, how we can reshape a NumPy array, and what we can do is that then we can see the slicing and dicing of a NumPy array, right? Are we all on same page in this regard? Okay, you're sharing your code. Khalid has done very good, Khalid.
But I have a question, if you allow me, for the dimension.
Yes.
So I created a multi-dimensional array with
Yes.
3 rows, but the
Okay.
dimension is as2. So this is the expected answer, right?
Yes. You
Okay, so
had
it
created multi-dimensional array. Yes, you got a 3 rows, 3 column. Your dimension for the array 0, Khalid, is 3 rows, 3 column. For the second array also you have taken the same dimension, and for the third array your dimension is absolutely the same. So you've taken a square matrix. You've taken a square matrix, right?
Yeah.
Okay, Khalid is through. Others, please share your code window, what you have done. this particular activity which I have given in the class right now, where you have to display the dimension, size, and the data type of the array that you're working with. For data type, you need to put D type. D type is the one attribute that will allow you to specify what is the data type of an array that you're working with, right? D type. D type is the data type of an array, or that particular attribute will help you to identify what data type you're working with. Everyone is on the same page. Everyone is doing it. Very nice. And you need to practice NumPy very well, because you will be working with NumPy and Pandas together. So unless and until you had a very good hold on NumPy, you will not be able to mix and match NumPy and Pandas together, because then you import NumPy as NP and Pandas as PD, and then you have to work with both these libraries together. So you need to have a very solid foundation for NumPy. Are we all on same page? Hassan has shared something that has, so Abdul and Hassan. Good. Is done the scalar multiplication, is done the dimension and size. Good, good, good. Then who's this is Hassan has done something. Hassan is using Spider, I hope so. He's using Jupyter notebook and he's using Spider. Very nice, Hassan. Hassan has done Bravo Charlie Alpha. He's taken 3 arrays. The name of the first array is Alpha. He's taken an array. The first array, the dimension is 2 rows and 2 columns. Bravo is the second array for Hassan, and he's taken 2 rows, 2 columns. Charlie is the third array, 2 rows, 2 columns. Then he added all the arrays, multiplied these arrays, and then he did a scalar multiplication. Good, very good. Sanjeevni, where is your output? Are you through, Sanjeevni?
Just a minute, sir. I'm sharing.
Okay, okay. Now we look into few more functions with the NumPy array. We will look into the arrange function, and we'll see what's the arrange function is in store for us. We'll see the line space function. We'll see np.0 and we'll see np.1 array, and how's the np.arrange, np.0, and np.arrange is going to give us the output, and how these output will be different from each other, right? So we'll write np.arrange and see what output we'll get if I write Z. I'll take a fresh window. Import NumPy as NP. Now we imported NumPy as NP. Now we will be creating an array using np.arrange, right? So there are different functions we can use. So what is the np.arrange function has got in store for us, right? np.arrange, suppose it create an array x1. So it's not, so np.arrange, what we are giving the parameter here, suppose I'll give 1 to 11, and then I'll print the array x1. So what output is, we'll get it in store. And how do we get it? So we created an array x1 The x1 is np dot arrange. It gives us the number from 1 to 11. Suppose if I give one more parameter 2, so I'll get 1, then I'll leave 2, then we'll go to the 3, we'll leave 4, we'll go to 5, then we'll go to 6, and then we'll go to 7, and if I give np dot arrange 3, so what is the output? So we can write it. If I write np dot arrange 101 and I'll give 5, so what's the output, guys? We are going to get it over here. 1 plus 5, that is 6. 6 plus 5, 11. 11 plus 5, 16. 16 plus 5, 21. 21 plus 5, 31 till 96. If we add 96 plus 5, it will become 101. It will become more than 101. So it will not take 10. It will take up to 100, right? Have you understood why do we write np dot arrange and what the np dot arrange has to do with this, right? Okay, Sanjeevni is through. Very good, Sanjeevni. She's done that. Everyone is through with this activity, right? Have you understood np dot arrange function in NumPy? Yes, guys.
Yes.
Here, arrange. Yes, yes. What doubt you have, Khalid? Are you facing any challenge with np dot arrange?
No, no, it's very clear.
It's very
It would be nice if you can quickly tell us a real life use case of arrange.
Yes, use case of arrange is basically we can create an array within a given range. Suppose I take another array x2 and I can write np dot arrange and I can take a given range. Suppose 1 to 500. I want to display all even numbers between the range 0 to 500. So I can use np dot arrange. So if I print x2 over here, what we can do, guys, we can print all the even numbers in the range between 0 to 500. 0 to 468. Are we getting all
Yes.
the even numbers?
Very clear. Thank you.
Okay. Now we go to the next very important thing is that we'll go with the next particular function. Here we use np dot zero. So np dot zero will give us a zero numpy array, and np dot one will give us a one numpy array. So how do we know that it gives a zero numpy array or it gives a one numpy array, right? So we can write like this np. I'll take a fresh code window, import numpy as np. Now what we are supposed to do over here, we're going to create a zero numpy array or we are going to create a one numpy array. So np dot zero is for the zero numpy array, np dot one is for the one numpy array, but we need to give the dimension, right? So I take y1 np dot 0 and I'll take the dimension, suppose 4 comma 4, and I'll take y2 is equal to np dot ones, and I'll take the dimension 3 comma 3. So what we should get, we should get a numpy array with 0, and we should get a numpy array with 1. So we can have a np dot ones or we can have a np dot 0. So np dot 0 will obviously return a array with all elements 0, and np dot 1 will obviously return the array with the all the element as 1. So let us print and see or display the output. So we'll get the output print y1 and will print y2, right? So if we print these two array, what is the output we'll be getting, right? So np dot 0. So np dot 0 is basically will get all the elements as zeros, but it should be np dot zeros, zeros. So it has to be s added over here. np dot 0 cannot interpret 4 comma 4 as a data type, right? So we'll have to check the data type that we are taking in np dot 0. Suppose I take 3 comma 4, or I'll change the data type np dot 0. Suppose 3 comma 4. So we have np dot zeros and np dot 1. So np dot 0 should provide us with all the element as 0. So np dot zeros, okay. If we print straight away rather than assigning, then we'll get this output np dot zeros. Let us check np dot zeros will give us a 0 array. So we have to check the shape of an array. Are we getting the shape of the array as a square matrix? If you don't get a square matrix, then we'll not get the array printed or displayed. So let us see whether the dimensions are matching or not. In case if the dimension doesn't match, we'll be taking the different dimension for the okay. So np x3 is equal to np dot zeros 3 comma 3. Now here the dimension is to be matching with the one that we are providing. So let us see.
Professor,
Just give me.
if you just allow me to
Yes,
comment here.
yes.
I've been trying to
Yes,
experiment
yes,
at
yes.
the same time as you with
Yes, yes,
Colab.
yes.
And the second parameter or argument is expected to be a data type. And I put in integer and it gave me the response of 3 zeros. And I changed it to string and it gave me this the output as 3 blank integers. Just
Okay.
int.
Just int, will it be giving us the integer? Let us check it once. Print x3 and np dot 0. Just int and giving it. Let us see.
Yeah.
Yes, but we want 2 dimensions here. So we should get 3 rows, 3 columns. So if I give int 64, it should, okay, we'll take with 1 dimension here, and then we'll gradually move into the second dimension. Instead of data type, we'll do D type. It works with data types. So let us see with the dimension how it works with the dimension. So np dot zeros and np dot 1. So np.0 should give us the 0 arrays. So let us do with this dimension and check whether it's returning the value that we are looking for. So here I have taken the 3. Yes, it works now. So we have to take np dot int 64. So here I can work with multiple dimension. We can work with 4 dimension also. If you can check, we'll get the array with different dimension. Are we getting it, guys? Is it clear now? np dot array with different dimension. So whatever the data type and the dimension that we provide. So if instead of integer, if we give it as float, it should work with the float also, right? So let us check whether we are getting np dot zeros as float. Yes. So it works with the 1 dimension, it works with 2 dimension. Is it okay? Are we all on same page with np dot zeros? Yes. Is np dot 0 is okay with everyone? Now we can have also multiple dimensions. That means we can have more than 2 dimensions. So how that will work if we go for more than 2 dimensions? Suppose if we take this one. So we have 4 elements. That means we have how many rows and how many columns? We have 2 rows. We have 3 columns. And we have instances of 3 rows, 4 instances of 3 rows and 4 columns. So this is np.0 with 1 dimension, np.0 with 2 dimension, np.0 with multiple dimension. Is it clear, Khalid, Hassan, Sanjeevni?
Yes.
Yes.
Okay, so we understood how np.0 works with different dimension and what exactly will be if we change the dimension, then what will be the output, how it will be impacted, right? Like np.0 we also have another array in NumPy that is called as np.1. So np.0s we have np.1. So let us do one np.1s and see how and in what format it will be displaying the output, right? So I'll take a fresh window. Now np dot, instead of zeros, if I write ones, what will be the output? So all the elements which were 0 converted to ones. All the elements which were 0 converted to ones. Similarly, I'll write np dot ones. So all the elements which were 0 are converted to ones. Here also np dot ones. So whatever the element that were 0 in the NumPy array, that is all converted to ones. So have you got the difference between np.0 and np.1? Is it clear?
Yes.
Are we all on same page with np.0s and np.1? Let me copy paste it on the chat box also with the output. So this is np.1s and this is np.0. So and the output for np.0s is all zeros and the output for np.1 is all ones, and the dimension can vary. It can be 1 dimensional, it can be 2 dimensional, it can be multi-dimensional, it can be 3 dimensional also. This one is 3 dimensional. Why? You got 3 rows, 2 column, and there are 4 instances of 3 rows and 4 column, like this. Same here, this is also multi-dimensional. 3 rows, 2 columns, and there are 4 instances of 3 rows and 2 columns. Is this clear to everyone?
Yes.
Now we'll move ahead and we'll go to the next one where we see an identity matrix. What is an identity matrix? An identity matrix is that matrix where all the diagonal element is 1. Identity matrix is that matrix where all diagonal element is 1. So how do we print or display a identity matrix using NumPy, right? So we can go to the code window here, and there we can write what is the syntax that we can provide for an identity matrix, right? So we got np.arrange. So np dot I is a function which gives us an identity matrix. So if we write np dot I, we'll get all the diagonal element as 1 1. So if I write np dot I 5 and 5, we'll get all the diagonal element as 1. Are we getting all the diagonal element as 1? And the matrix that we are displaying is an identity matrix. We are getting all the diagonal element 1, and the matrix that we are displaying is a identity matrix using NumPy. np.I. np.I is very important function, right? Now, if you want to shift the diagonal element 1 place to the right, suppose we want to display a identity matrix where all the diagonal element is 1. Now we want to shift all the diagonal element 1 places to the right. Then what exactly is the parameter that we are going to add to this function, right? So np.I, if I write k equal to 1,
एक तो करते नहीं हूँ, दूसरा टाइप करते हैं, दूसरा करते नहीं हूँ, तीसरा टाइप करते हैं।
so what we can do is that we can put this diagonal element 1 place to the right or 1 place to the left. Let us see, it should be comma here, not dot. So what happened, instead of starting from 0 0, the diagonal element here started from 0 1. So this is the index 0 0, this is the index 0 1, this is the index 0 2, this is the index 0 3, this is the index 0 4, this is the index 1 0, this is the index 1 1, this is the index 1 2, this is the index 1 3, this is the index 1 4, this is the index 2 0, this is the index 2 1, this is the index 2 2, this is the index 2 3, this is the index 2 4, this is the index 3 0, this is the index 3 1, this is the index 3 2, this is the index 3 3, this is the index 3 4, this is the index 4 0, this is the index 4 1, 4 2, 4 3, 4 4. So here there is no 1. 1 is shifted 1 place here because k equal to 1. If I do k equal to 3, what will happen? K equal to 2 is shifted 1 place more. The index has shifted 1 place more. So np.I gives us the identity matrix where we can shift the index to 1 place to the right, 2 place to the right, or 3 place to the right, depending on the inputs that we are providing. So np.I is the one function which provides us with that particular range. So is it clear? np.I. Is it clear what exactly it does?
Yes.
Everyone?
Yes.
Yes.
Are we all? So what we did with NP.0, we with the data type, with data type it is taking, without data type it is not taking. So we taken the data type explicitly, whether integer or float, then it gives us the multi-dimensional array. Same we did it for np dot once, which gives us one multi-dimensional array. Then we did np dot I, which provides us with the identity matrix, right? Now we'll move ahead with another very important function with NumPy, and that particular function is a line space function. So what is a line space function does? Let me give you a little bit brief idea about that. It returns you a value in a given range. Okay. So what the line space function is doing, it will give you the values within a given range. So if you specify the range, the line space function will give you the values within the given range. Okay. So let us execute a line space function here. np dot array, np dot line space. Now I want, what we want guys, we want the numbers to be displayed in the range. So what is the numbers that we want to be displayed in a given range? So line space, we want a number between 1 to 10. So I'll give a range of a number 1 to 10. Suppose I want 20 numbers in the range 1 to 10. What we want 20 numbers in the range 1 to 10. So are we getting a 20 number in the range 1 to 10? Okay, so we need to import numpy as np, otherwise this will not work. Import numpy as np, and then what you can do, you can assign this to some variable z1, and you can print z1. So we can see what output we are getting. I run this code. Z1 is np dot line space. So np dot line space will take this parameter. It's not line space, links are lins, lins. Okay. So if we run the code, what output we are getting? We are getting 20 such output, that is in the range between 1 to 10. So linspace function in NumPy will provide us with the range of values between 1 to 10. So how many numbers it is giving? 20. So suppose if I take another array or a NumPy array, np dot linspace. Now here I take a different range 1 to 100, and the number of values I'm going to display is suppose 50 values, 50 like this. So we should get 50 values in the range between 1 to 100, 50 values. So if we print z2, are we getting this output? Are we all on same page? Yes, guys. Yes, Abdul, Hassan,
Yes.
Yes, yes, sir.
Sanjeev, Khalid, have you understood?
Yeah.
Yes, Khalid, is it clear?
Yes, sir. Yes, sir.
Very good. So we did with np dot linspace, we did with np dot once, we did with np dot 0, we did with np dot I. I is the identity matrix, and then we change the value of the identity element in the matrix one by one, right? So these are the very important function that we use in NumPy. So whenever we are working on a NumPy, we take some special care about this. There's another function in NumPy. So this function is a randomly we can generate. numbers. Suppose if you want to generate a random number between a given range, or suppose if we want to generate a random number, any amount of random number, then we can use this function, which is where it comes very handy, because when we combine numpys with pandas, we generally use this random or randit function, right? So how this function works? This function we can write import numpy as np. Then the random function, we can write it like this: np.random, np.random, and then we can have after np.random we can have randit, ran, and we can specify the range 2 to 10. So np.randit will give what? It will give a range 2 to 8. It will give random number in the range 2 to 8, right? So if we want total number, or suppose if we want 50 random values within a given range, if we want 50 random values within a given range, then how we can go about with this, right? So we can just write like this: np dot random. We want a
Sir,
random. Yes.
sir, in the
Yes.
same what we have done now, your output is 8, but for me I got 5.
Because the numbers are randomly generated in that particular range. So I may get 8, you may get 5, somebody else will get some different number. So it will take random values. It's not fixed for everyone, right? That is why it is
Okay,
random. Okay. So we
okay.
have np.random, then we have rand. Rand is the random function that we take, rand. Suppose we want 20 random numbers, right? So what output we should get? Like this, we're getting 20 random numbers. Now I'm getting 0. 0.9, 0. 0.06, 0.34. You may get some different random numbers, but you'll get 20 random numbers, right? But we will not get the same random numbers. Clear? We'll not get the same random numbers. We'll get different random numbers, right? Now if I want a random number in a given range, then what syntax that we can provide so that we get a random number in that particular or in that specific range? So we can write like this: np dot random, and we can use the random function. And suppose I want random numbers between 1 to 50. How many numbers I want a random number between 1 to 50? Suppose I want 20 random number in the range 1 to 50. So if I run the code, you can see we are getting 20 random numbers in the range 1 to 50. Now the random numbers that I am getting, you might not get the same random numbers, right? Number that I am getting, you might not get the same random numbers. So have you understood how is randit function or random function works in NumPy, and it gives us the random, uh, basically the random number. So this particular will give us the random number. So the random numbers which are generated will be different for everyone. So we're not going to get the same random number in the NumPy array like this. Okay. So NumPy array will return us with different range of random numbers. Is it clear? I'm putting the code in the chat box. Have you understood this one? Are we all on same page, guys? Any
So
doubt?
the last one is to basically give a number between to give 20 numbers between 1 and 50, right?
Yes, yes, yes.
Okay.
Correct. It gives you 20 random numbers. The 20 random numbers that you are getting, I may not get the same numbers because they are randomly selected.
Clear.
Okay. So whatever the number Khalid is getting, Hassan may not get the same number. Whatever the number Hassan is getting, Abdul may not get the same number. Sanjeevni may get a different set of numbers. So everyone will get a different set of numbers. We are not going to get the same set of numbers, right? Clear? Are we all on same page?
Yes, sir.
Yes, sir.
Very good. We should be all on same page, right? Now, the numpy array can be of different type. It can be an integer array, it can be a boolean array, or it can be a particular type of array. So we know that the type or the data type of an array can be specified, which can help us to mention what exactly is the data type of an array that we are working with. Are we working with an integer array? Are we working with a float array? Are we working with a character array? So basically the data type. So how we can specify the data type of a numpy array? We can write like this in our code window. How we can write it like this? We write like this: import numpy as np. So we are imported the numpy as np. Now, what we want to specify is the data type. So, suppose we taken an array here, we have taken an array x3. X3 is an array that we have taken, right? Now, in the x3 array, what we want to specify? We want to specify the data type in the array x3. So, we write np.array and then we give the data type of that array which we are trying to specify, right? So, we can write like this instead of. So what data type it will show us? It will show us if we print x3, it will show us the data type as float. All elements are float. 2.0, 3.0, 4.0, 5.0 and so on. So we can display the data type, right? Now instead of float, if we write as integer, then it will show integer. Let us change it a little bit. So I'll take the array x4 instead of x3. We're going to take the array x4, and instead of float, I'll change it to integer int, and we display the array x4. So we'll get different values. All values are here in what? They are all in float, right? Now we can have a Boolean array. Boolean array means all the elements in the array that we are displaying will be either true and false, right? So how we can have a Boolean array? So we can take a array variable b1 and then we can put it np.array is equal to true, true, false, false, and then we print b1. So that will give us a array with all the variables as true, true, false, 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 like this, right? And then we can have a array which can take a complex. Complex means a plus ij. That is a complex. So we can have a complex array and we can display a complex array in a numpy. So suppose we take a complex array C1, and here we print this complex array C1. So that will generate the code accordingly. So see, we have taken an integer array, we have taken a float array, we have taken a Boolean array, and we have taken an array with complex number. Is this is clear? NumPy array with different data types. NumPy array with different data type. So are we all on same page with the data type that we use in a NumPy array? Are we all on same page, guys? Yes.
So wait 1 minute.
Yes, you all do this one.
Yeah,
Have
just
a
last.
NumPy array with different data type, right? And next we come down to the slicing and dicing in a NumPy array. Very important. How do we do the slicing, dicing, and indexing in case of a NumPy array? So how do we index? Yes, Sanjeevni, Abdul, any challenge you're facing?
Sir, it's taking bit time. You're so fast.
Okay, okay. So
Our speed, we cannot manage the speed with you.
okay, okay, I'll be slow. Okay, I'll move slowly. You all do this. Once you all do this and share it on the chat box, then I'll move to the slicing and dicing. Okay, take your time, no issue. You all do
Thank you,
this,
sir.
share the output in the chat box. I'll go very slowly and then we'll do slicing and dicing. Take your time, no problem, guys. I'll go very slowly.
I just have a question, Professor. The empty,
Yes, empty
is that
means the one. It's a null array. Means there's no value. Empty means nothing. It's null.
okay? And then when you specify the type as complex 64, does that enforce the array to have values? Because I see the printed array has values if you scroll down.
Yes, it gives a complex number. What is a complex number? It takes a random complex number, because how many complex number it will take? 9, because it is a two-dimensional array. It has got 3 rows, 3 columns. So it will take 9 complex value. It will
Okay.
take by itself. You are not assigning any value. It will take it by itself, right?
Yes. So if we remove the data type np.complex64, this will
Yes.
actually print an empty 3 by 3 array, right?
Yes. So
Okay.
do that and see, if you remove it, it will not print anything. But if it you giving the data type complex or data type boolean or data type integer or data type float, it will explicitly assign that these values become float, integer, boolean, or complex.
And it will automatically use random function.
Yes, yes,
Okay.
yes. You may not get the same complex number when you run the code, right? You may have a
Okay.
different set of complex number.
Okay.
No, it's same, man.
Are you getting same?
Yeah.
Okay. So I'm going very slow now. Everyone, please share your output in the chat box. So once everyone is through, then I'll move to the slicing and dicing in NumPy, right? And then we'll combine NumPys and pandas together. And that will be a cocktail of NumPy and pandas, right?
What we have to show in the chat box?
You have to show the data type, Sanjeevni. Number one, you have to show me the line space function as np.zeros and np.ones. This you have to show with line space, np.arrange, np.line space, np.data type, np.random function. I'm writing out what you have to show in the chat box. So once everyone is on the same page, I'll move to the slicing and dicing. Till I see the output, I'm not moving to the slicing and dicing of one-dimensional and multi-dimensional array using NumPy, right? So I'm writing what you're supposed to post in the chat box. Random, np.random, line space, range, np.0, np.1 once, then np dot zeros, np dot ones, np dot we have done arrange random dot rand function or random. So this is what you are supposed to post. Abdul has already done it. Fine, Abdul, but Abdul has got errors also. Try to resolve it, Abdul. Module NumPy has no attribute boolean 18, so it's not supporting bool 18. So just give boolean, whether it shows boolean. I think the boolean is boll8. It's supporting in my one, it's not supporting in your Google Colab. It's given the name attribute error for data type d boolean.
Okay.
So
That-
everyone is on the same page, everyone is trying it. np.random, np.linespace, np.arrange, np.zeros, np.I. I forgot I. I should be also there.
I did it all.
You all did it all, Sanjeevni.
Yeah,
Just
yeah. I
put
was
the
going
screenshot
through
on.
only.
Okay,
Okay.
okay. Then put the screenshot on the chat box. That I'll know that we all have done it.
Okay.
Fine, fine. Everyone is doing it. Very nice. So once you do it, then we start with the slicing and dicing. Slicing and dicing and indexing is very important. How we slice and dice one-dimensional and multi-dimensional NumPy array, and how do we index the element in an array, which is very important for every one of us to know, right? So we should know how we can do the slicing and dicing and indexing. Slicing, dicing, and indexing in a NumPy array. Very, very important.
Sir, still the same error coming. So can you please tell me once again what I need to type to remove this error what I have shown you earlier in the chat box?
Okay, I'm just copy pasting the code here on the chat box. Abdul, what you do, you just execute this code by importing NumPy as NP.
Okay, sir.
Do let me know once you are all through, then we can start with slicing, dicing, and indexing of NumPy array, right? Okay, Sanjeevni has done. Good, Sanjeevni.
Yeah.
Excellent. Khalid has done. No, he's not done right now. Hassan has done. Abdul, are you doing? Abdul?
Yes, sir.
Very good.
Done.
Done. Very good.
Yes. Thank you.
Now we start with the next portion. The next portion is how we can do slicing, dicing, and indexing in one-dimensional or in multi-dimensional NumPy array. So if you are working with a one-dimensional NumPy array, how you index your one-dimensional NumPy array. If you are working on a multi-dimensional NumPy array, then how you will be indexing your multi-dimensional NumPy array. So it's very, very important, guys, that we know how the slicing, dicing, and indexing has to be done and how it has to be represented in case of a NumPy array. So let us create a multi-dimensional NumPy array so that we can start up with the slicing, dicing, and indexing, right? So I'm taking a new fresh code window. I'll give you all the screenshot of the code in your Gmail account, right? So don't worry. I'll give you all the screenshot after the class. Import NumPy as NP, right? So we all do like this. Import NumPy as NP. Then what we do, we create a multi-dimensional array. So suppose we take an array, suppose x21 is our multi-dimensional array, and this array will have for suppose 4 columns and it will have 3 rows. So 4 columns and 3 rows means we are going to write np.array, right? So we'll do np.array, and in this np.array we'll be specifying the indexing, slicing, and dicing that we will be doing, right, with this particular array. So let us specify 2, 3, 4, 5. First one, then comma, then second one, 4, 8, 9, 11, then comma, then third one, 9, 6, 7, 12, right? So how many rows, how many columns we have in this array? How many rows, how many columns? We are having 3 rows and 4 columns. It's a multi-dimensional array. It's a multi-dimensional array having 3 rows. How do we know that it is multi-dimensional? So it has got 4 columns and 3 rows. Now what we are supposed to do? We are supposed to do the slicing, dicing, and indexing. So if we write 0 comma colon, it's for the first row that will be displayed. So we'll do that and we'll see what happens if I print. Now what we are going to do, the slicing and dicing operation, we'll print the first row. So we'll write 0 comma colon, right? We'll write 0 comma colon like this. So what output will be getting? 0 comma colon what? We have to specify the name of the array, right? So here the name of the array in the square bracket. So the name of the array here is what? X21 square bracket like this, and the square bracket should be ended. Are we getting the first row, everyone? Are we getting the first row? Yes. What
Yes.
we are getting over here?
2,
We are
3,
getting
4.
the first row. Now, if I change it to 1, suppose instead of 0, we make it as 1. So, are we getting the second row? 1. So, what we have done, we have changed the first row and we made it a second row. If we want to have the third row, we can do the third row also, right? So, slice change in the code. If we want to have second, so we'll have the third row, right? So what we can print the second row, We can print the third row. Suppose this is the first row. We can print 0th row, right? So 0, 1, 2, these are the rows we are printing. Got it?
Yes.
Now, what will happen if we change the indexing? Indexing means instead of writing 0, colon, if we write 0, colon 1 or 0, colon 2 or 0, colon 3. So, will it change the something in the code? Suppose if we write like this. 0, colon 1. So what are we going to get?
2 only.
2 only. So why we are getting 2 only? Because in the first row and in the index 0 and 1, that is the second element, it will be 2. So basically we are getting 2. So where is the 2 located here? The first element in the 0th row. So basically that is the 2. Okay. So that is if we change this index, means instead of writing 0, colon 2, if we write 0, colon 3 or 0, colon something else, so what we'll be getting? Suppose I write here, we print x to 0, colon, instead of 1 we are writing 2. So what change in the output we are getting?
First
2 and 3.
2 and 3.
So it takes that first 2 element, right? So if we print 0, colon 3, if we print 0, colon 3, so it will take which element, guys? It will take the
3, 4.
2, 3, 4. 2, 3, 4. If we print 0, colon 4, so it should print all the element in that particular row 1. Are you getting the output? How it is changing the output? 0, colon 1, 0, colon 2, 0, colon 3, 0, colon 4, right? So these are the output that we can get. So basically, these are the output that we will be getting when we display 0, colon 1, 0, colon 2, and 0, colon 3. So what we are doing, we are changing or we are slicing and dicing this multi-dimensional NumPy array, right? What we are doing, we are slicing and we are dicing this multi-dimensional NumPy array. So instead of 0, colon 1 or 0, colon 2, we can write like this: print 1, colon 0. So instead of writing this, can we write like this: 1, colon 0 or 1, colon 2 or 2, comma colon? So can we do this so that we can see 1, comma colon, what does it prints? 2, comma colon, what does it prints? 1, comma colon. So we write 1, comma colon, just 1, comma colon, or we write 2, comma colon. So 1, comma colon, if we write not 0, so it will change it accordingly. Gives this 4, 8, 9, 11. That means the second row. Okay. If you want to print the third row, we can write print x21, 2, comma colon. So what it will print, guys? It will print the next row in sequence. I'm putting this code in the chat box with the output for your reference. See that. So you can compare the slicing, dicing, indexing with the output. So what you can compare? You can compare the slicing, dicing, and indexing with the output. Is it visible to everyone? Khalid, Sanjeevni, Abdul, Hassan.
Yes.
Yes.
So what we are doing, guys? We are doing slicing, we are doing dicing, and we are changing the index. So
Index.
if we change the index, then our elements that we display also change. So if you change the index, so obviously the elements that you are displaying will also change, right? You will display a new set of elements. So suppose if I write like this, array 2 here in this particular code window, if I write print x21, and the index we are changing here. So what is the index value we are changing over
2.
0 colon 2? So 0 comma 0 colon 2, 0 comma 0 colon 2. So if we change the index like this, the element that will be printed will also change. If I run the code, see,
Okay.
2, 3. If I change the index, if we change the index like this, instead of 0 colon 2, then if we change the index 0 colon 3, 0 colon 3, and we check the output will change. See, it's changing. So instead of writing like this, if we write 1 colon 2, 1 colon 2, or 1 colon 3. So the slicing, dicing, indexing will change accordingly. You can see 3, 3, 4. 3, 3, 4 means it is taking 3 and 3, 4. This one. First it takes 3 and then it takes 3, 4. If we change the index 1 colon 4, so what is the output that we'll get? We'll get a different output like this. So what
3.
exactly we are playing? We are playing with the slicing, dicing, and indexing in a multi-dimensional array. So we are having a multi-dimensional array, and what we are doing? We are doing the slicing, dicing, and indexing in a multi-dimensional array so that our output will be displayed accordingly that we get in the code window, right? So this is the code window, and this is the slicing dicing operation that is giving us the different output on this multi-dimensional array. Are we all on same page in this regard? Yes, Khalid, Abdul, Hassan, Sanjeevni, are you all
Yes.
understanding? Are we all on same page, Khalid? Yes, Khalid, are you facing any
Yes.
challenge?
Yes.
Please let me know.
No,
Very
things are good.
nice.
Thank you.
Okay, very nice.
Sir, I want
Hassan
to
and
ask one question.
yes, yes, you can ask me 100
Sir,
questions. Yes,
as you
tell me.
mentioned over here, slicing and dicing, like what is the like how we can distinguish between these two?
Slicing and dicing means what we are doing is that we are indexing the each element in an array. Every element has got a index. Index means it has got a position. For example, Abdul, if you see this one, in this array, we have 3 rows and we have 4 columns. So every element in the array has got an index. Row 1,
Yeah. Yes.
column 1, row 1, column 2, row 1, column 3. So 2 is 0, 0, 3 is 0, 1, 4 is 0, 2,
0 2
5 is 0, 3,
0 3. Yes.
4 is 1, 0, 8 is 1, 1, 9 is 1, 2, 11 is 1, 3,
3
9 is 2, 0, 6 is 2, 1,
2
7 is 2, 2,
2 2
12 is 2, 3, right?
3.
Now, if I have to
Yes.
add if you have to access element, I don't want the full array. From the total array, I want the first 3 element of the row 1, or I want the first 4 element of the row 2. Then I have to do the slicing and dicing. Means I want to not to get the entire array, but depending on the index that we have provided, we'll access few elements
Mhm.
from the array. So that is what is called as index slicing and dicing. Means we are not taking all the elements from the array, but we are taking
Mhm.
few selected elements from the array as per our
Mhm.
requirement, based on the index that is provided. Understood? Is
Yes,
it
sir,
clear?
it's clear now. Better,
So
yes.
because
Thank you.
every element has got an index. So if I write 2 comma colon, that means what? 2 comma colon means I will get all the element which is in the row 2, that is 9, 6, 7, 12. Are we getting it? Yes, we are getting it. If I write
Yes.
1 colon, that means I'll get all the element in the row 2, row 1, right? Row 1 and row 2, because here you see 4, 8, 9, 11. That means we are getting this particular element. If I write 1 colon, because this is row 0, this is row 1. So if I write 1 colon, I'll get all the element in the second row. If I write 2 colon, I'll get all the element in the third row. If I write 0 colon, I'll get all the element in the first row. If we write 0 colon, means if we write the opposite, means instead of writing 1 colon, 0 colon, 2 colon, if we write 0 comma colon 1, 0 comma colon 1, what output we are getting over here? We are getting the first element in the first row. The first element, that is 2. First 2 element in the first row. First 3 element in the first row. First 4 element in the first row. That is what we are getting: first element, first 2 element, first 3 element, first 4 element, right? And then we get 4, 8, 9,
Yes,
11.
sir.
So all the element in the second row, all the element, 3 element from the second row, 2 element from the third row. So what we are doing, we are indexing, we are slicing, and we are dicing the array. So what we are doing, we are indexing, we are slicing,
Yes, very
and
true.
we are dicing the array. That means we are cutting the array into pieces, right? Slicing,
Mhm.
and we are
Yes.
indexing, and we are getting the element from there, right?
Yeah.
Understood? Are we all on same page, guys? So Abdul has understood, Khalid has understood, and Sanjeevni has understood, right?
Yes.
So what we did today, let me have a brief recap. I always believe in doing a recap, what we have done, what we will be doing, and where we are going ahead, right? So we did with NumPy today, okay? And in
Mm.
NumPy, we have seen how we define one-dimensional and multi-dimensional array. In NumPy, we did with lot of things. We did with NumPy 0 array, NumPy 1 array, NumPy identity matrix, multi-dimensional array in NumPy, matrix addition, matrix multiplication, matrix division, scalar multiplication with matrix that we have done with the NumPy array today. What we have done today, we did with in slicing and dicing in NumPy array. We did with NumPy dot arrange, NumPy dot line space, NumPy np dot I function we have done, np dot random, random it function we have done, M, np dot empty function we have done, np dot arrange function we have done, np dot line space function we have done, np dot random it function we have done. We have seen the data type in the NumPy array, the dimension in the NumPy array, the size in the NumPy array, right? What we did with all these things, and then we did with the shape, dimension, and size, okay, and the data type. And then we did lot of slicing and dicing in NumPy array. And then we did with the scalar multiplication,
Hello.
I think we lost Professor
Yeah.
Shant. Okay. I think I will also go. Thank you very much. Good night, everyone.
Good night.
Seeing and matching here. So we can
Oh,
and how
he's
in
back.
NumPy
Oh, you're back. Okay. We lost you for a few seconds there. We can't
Again, we
hear-
lost.
Yeah, I think the audio is gone. Still, we
Oh.
cannot hear you. We can't hear you, Professor.
We can't hear.
No, there's no sound at all. It's not like it's far. It's disconnected, it seems.
No, we can't hear you, sir.
No, still can't hear you. Anyway, I think we all deserve a break.
Yes. Am I audible now?
Yes,
Yes.
now I hear you, yes.
Okay. So what I was telling you all guys is that I was just putting a recap what we have done today, right? I'm not going into any new topic. We have almost complete lot of things in NumPy. What was I was providing you is the recap. So we did with lot of things in NumPy. We did with NumPy with a 0 array, NumPy with ones array. We did with slicing and dicing with a NumPy array. We did with dimension and shape of a NumPy array. We did with matrix addition, multiplication with a NumPy array. We did with arrange and line space function, identity matrix in a NumPy array, random it function in a NumPy array, and what we have done, slicing and dicing. Okay. So next day, what we will be doing, we'll combine, we'll do filtering on a NumPy array, and then we'll start with pandas, right? That is in the next session, right? I hope you all enjoyed this practical session on NumPy, which is very important in data science application. And pandas is also very important, and we'll work with some data set with pandas and then combine NumPys and pandas together. Okay. So that's all for today. Bye bye.
Thank-
Hope you all enjoy. See you again. Bye bye.
Yeah, thank you,
Thank
sir.
you
Good
so
night.
much, sir, for the session. It was a wonderful session today.
Okay, I'll share the recording. Okay, bye bye.
Bye-bye.
Thank you. Bye. Good night, everyone.
Good night.
Good night.
Good night.